So today we're going to do our third lecture, building on the earlier two. As you recall, the first lecture focused on how do we attach value to alternatives that have multiple attributes, but where the attributes are certain. So for example, if you take a job, the salary they offer you and the vacation they offer you are pretty much what you're going to get. So there's certainty, but there's still trade-offs. So lecture one dealt with those trade-offs. Lecture two, we added uncertainty, and we had to deal with the issue of how people feel about risk, and developed utility theory, and focused mainly on the utility of money and risks associated with money. Well, today we're going to deal with the question of multiple attributes, which is not just money, but other things, money and performance, money and other kinds of benefits. And we're also then going to deal with multiple stakeholders, where there's more than one decision maker. We're going to focus first on multi-attribute utility theory, utility independence, and come up with an assessment procedure, and then talk about an example how it was used for procurement decision making. So here we have our multi-attribute utility function, and you can see the utility of the overall set of attributes x is related to x1, x2, xn, so there's several attributes, and we would like it, if possible, for the overall utility function to be a function of the individual marginal or component utility functions. So much like it is in probability theory, when distributions are independent of each other, we can actually compose the overall function from the independent functions rather than having to assess across all combinations of variables at once, which is very difficult. So we're first going to talk about utility independence. And basically, x is utility independent of x2 when the preferences for x don't depend on the value of x2. And if x and y are mutually utility independent, then we can form this multilinear function. And I'll talk a little bit later what this cross term does for you in terms of its impact on the ultimate best decision. So this multilinear form we're going to carry through. It'll be much of the first half of today's content. So we're first going to talk about utility independence. Let's say we had a lottery. Again, recall, this is where you make a decision. This is where nature decides. And in this lottery, you could get either the worst values of x and y or the best values, or you could get the best y or the best x. And the question is, what do you prefer, A or B? Well, it turns out if you're indifferent between the two of those, that you feel they're equivalent, then you're actually mutually utility independent, and you can actually collapse this to just the additive form. And we'll be using the additive form especially later in the lecture. So we have two forms, the additive form, the multilinear form, and the conditions under which they occur. Now let's try to assess our constants. In this case, we'll look at the constants in the additive form. You can see here that when x is at its best and y is at its poorest, we just basically get k1, because we get k1 times 1, k2 times 0, and the 0 right here, so that term drops out. Similarly, when we have the best value y and the worst value of x, we just get k2 because this drops out as 0, this is 1, and this drops out as 0 too. So that's where the k1 and k2 come from. Now let's consider a lottery where you're either going to win the best value y, or nothing, the worst value, or some other value of x, or the worst case. We'd like to know what x prime is such that you're indifferent between A and B. Now we're going to assume that actually x is the preferred attribute. So what that means is the utility of the best for x1 will be higher than the utility for y1. And basically what that means is this x prime is going to be less than x1. In other words, if this x prime was x1, you would surely pick A all the time. Okay? So there's some value of x prime less than x1 where you are indifferent. If you're indifferent, then by definition from lecture 2, basically you're indifferent between A and B, then their expected utilities must be the same. So we first plug in the whole notion of expected value, probability times utility. They're all 0.5, as you recall. Okay? These two utilities are 0 by definition, right? And the 0.5s drop out, and so we get this function right here, that the utility of x prime is equal to the utility of y1, if you will. So if we substitute in our general multilinear form that we had earlier, we get one equation that K1 x ux equals K2. So now we have one equation with two unknowns. So we're going to need another equation. Okay. Notice here that it's important that x is the more desired attribute because you wouldn't want the situation where x prime ended up greater than x1. You'd be out of the preference space, which creates all sorts of awkwardness, and you have to redefine the preference space. Now let's have another lottery. Now in this lottery, you can either win the best of x or the poorest, or you could win the best of y and a little bit of x double prime. This will be smaller than x prime. Okay? It'll be closer to x0 because you're getting the best of y1 also. I realize, by the way, these lotteries are kind of abstract. And so you might find it hard to imagine yourself making this decision as you see it right now. But when we show you a very specific example in a few minutes, you'll see that it is quite tractable for you to decide what you prefer or what you're indifferent about. So we assume that we find x double prime such that you're indifferent between C and D. And we then say, okay, if that's the case, expected utility must be the same in both cases. We just put in our equation for expected value. Again, this is 0, this is 0, this is 1. Okay. You drop out the 0.5s because they can cancel, and we get this equation right here. We substitute into our general multilinear form, and we get this equation with our constants. And we can solve it like this for equation 2. Now equation 1 and 2 give us two equations, two unknowns, and we just need to play a little bit of algebra, and we end up with these equations right here. So basically you can see the numerator is the same, denominator is the same in all cases, and we have our different coefficients here. Okay? And so now we know how to calculate the coefficients based on asking you your indifference points for two different values of x prime and x double prime. Okay. So this solution, by the way, is similar if we were developing a multi-attribute value function, although we didn't talk about that in lecture 1. So what's our interpretation of this cross term, kxy, or 1 minus k1, k2? Basically, if you prefer this combination to this combination, it means the attributes are complementary. You would like to have them together. Okay? So k is greater than 0. If you prefer this lottery to this one, it means that they're substitutable. K will be negative, and it means you'd be willing to give up one attribute to get a little more of the other one, or vice versa. Okay, so substitutable or complementary. Now let's talk about our assessment procedure. I've used this many times with decision makers, and here's the process we go through. First of all, you have to assume the decision maker is not an expert in this methodology. You're simply trying to help them to make a decision. And what they are usually motivated to do is to try to make a decision that is more systematic than what they would normally do intuitively. So usually it's an important decision or a large decision. So first of all, we introduce the terminology and the ideas and structure the preference space. What are the attributes? Find the limits and the orientation of the attributes. Does preference increase with the attribute or decrease, for example? We identify relative independence assumptions. Now, we obviously cannot ask them directly, are you mutual utility independent? They won't have the slightest idea what we're talking about. So what you do is you propose lotteries, paired comparisons, say, do you prefer A to B or B to C, or are you indifferent? And in that way, you can figure out whether or not the attributes are independent in the way that you'd like. Then we assess the conditional utility functions, utility for x1, x2, x3, etc. Then we assess the scaling constants using the equations we just developed. Then we check for consistency and iterate. We want to try to find if the decision maker agrees with the choices that produce maximum expected utility. Now sometimes the decision maker will find the recommendations counterintuitive. And in my experience working with many, many executives over the years, if it's counterintuitive, they won't accept it and just do it because your model calculated it. They need to figure out why things are happening and get enough insight so their intuition shifts. And that's very important. They need to have a gut level confidence in what's going on. So here's an example. This is a large library in Boston. And the manager of acquisition wanted to be able to delegate his decision for acquiring books. They were acquiring many thousands of books per year. And he was making these decisions himself rather than having his staff make the decisions. because he was concerned that they would not make decisions consistent with his preferences. Okay? And the basic decision boiled down to this. You can buy the book from the publisher with a fairly quick delivery, but little if any discount, because you're just buying one copy of the book. Or you could buy the books from wholesalers. Okay? They tend to buy thousands of copies from the publisher. They get a huge discount, and they're willing to share some of that discount with you. Okay? But they may not be as fast as going directly to the publisher. We end up with two attributes, discount, which in this case vary between 0 and 40%, and service time, which vary between 0 and 100 days. So given these two attributes, the question that the manager of acquisitions has, how do I come up with a method of telling my staff members how to make decisions about these two attributes consistent with my preferences? Well, first of all, we had to come up with the probability mass function. It's a mass function because these are discrete variables. Discount of 1%, 2%, 3%, days of 1 day, 2 day, 3 days. So it's a probability mass function. If D and T were independent, then we would be fortunate enough that our probability would just be the two marginal probabilities times each other. However, they aren't independent in this case. High discount books tend to have a small t. They're high discount because the wholesaler buys many copies of them. He'll share some of that discount with you, and they're on the shelf so they can ship them quickly. Low discount books tend to have a longer t, in part because there are not as many books on the shelf when you order it. So we ended up having to categorize books into trade and non-trade. So non-trade would be like an engineering textbook, and trade would be like the latest John Grisham thriller. Using data from the acquisition department's purchase orders, we estimated the probability of discount and probability of delivery time for the 4 sources and 2 categories. The 4 sources were the publisher and 3 wholesalers that the books could be ordered from. We assess the utility independent assumptions by showing the decision maker some paired comparisons and some lotteries, and his decisions confirm that we can make these assumptions. We assess the conditional utility functions just in the way we talked about in doing it in lecture 2 and fit the curve to them. The utility for discount, you see, has sort of a diminishing return shape in terms of its utility function, and then the utility for time tends to go down and asymptotically approach 0. You notice I got 2 utility functions here, non-rush and rush. The manager said, you know, when a faculty member comes into me and says they need a book right away for some research, that's a rush book, and they want it right away. And they're going to call me back in 2 or 3 days and say, when am I going to get it? Well, we're going to treat those books differently than the books we're acquiring that are just on the departmental's annual wish list. So there we have 2 categories. We assess the scaling constant and use the equations, and the 2 lotteries, the X prime, X double prime lotteries I showed earlier, we use those, assess the constants. And here you see, for non-rush books, he places much greater weighting on the discount, and the discount and delivery time are substitutable. He's willing to give up a little bit of discount to get the book faster, or willing to take a little bit of a delay in getting it to get a bigger discount. So they're substitutable. Okay. Notice for rush, it's simply U of T. He just wants the book as fast as possible. Discount doesn't matter. So then we fill out our overall utility function. This equation here is simply the definition of expected value, or expected utility in this case. We plug in our multilinear form, and here we have our equations. We plug in our constants, and we can actually calculate the value of all the alternatives. Now, here's what resulted. You could imagine putting all these calculations into a computer or a laptop, or maybe even an iPhone nowadays. However, that's not what he wanted. He wanted one piece of paper to hand to his staff that enabled them to make the decisions in a way that's consistent with his preferences. So here we have the 3 wholesalers, A, B, and C, and the publisher, D. So here the preference basically says if it's a rush trade book, order it from the publisher. A rush non-trade book, order from the publisher. If it's non-rush, the publisher is the last choice because they're the most expensive. Okay. A and B are all 2 alternative wholesalers here. Wholesaler C does not provide trade books. Wholesaler C plays a role in the non-trade books. These obviously, for the people, the staff in his office, were actually names of companies, not just A, B, C, and D. But what we have created here is a solution that allows him to delegate this task for him not reviewing thousands of books per year and deciding where to buy them, and letting his staff do it so that he's able to delegate the task and he can pay more attention to managing the overall department. This is often a problem we encounter where the decision maker wants a decision support system to make decisions in a particular way so he can delegate the decision and not have to be so involved with it. Some observations. First of all, we had to spend some time to get the decision maker to understand the intuition behind these choices. Often we had to look back at his choices, like his choices of x prime and x double prime, for example, and see how that influenced the resulting equation and the resulting decision recommendation. We needed to focus on the average case. As I recall, he remembered one faculty member who 20 years ago had some really unusual request. And I said, when that happens, just deal with it any way you want. This is for the 99% of the cases that aren't like that. Beyond any data collection and programming to solve this problem, we spent 7 to 8 one-hour meetings with the decision maker to actually formulate the problem, get his preferences, and actually interact with him to look at the solution and see whether or not that made sense to him. We would obviously need to update these guidelines if the probability functions changed or new sources were considered. But here's a good example where our utility theory, our multi-attribute formulation, allowed us to support a decision maker to make a decision that was consistent with his overall values about the attributes at hand, and then delegate that decision because of the formulation. Now, let's switch gears a little bit and talk about situations where there is not one decision maker, there's multiple decision makers. How do we deal with that? And we're going to talk about this in terms of Arrow's impossibility theorem. Ken Arrow won the Nobel Prize in economics. He's one of 5 Nobel Prize winners in economics we'll talk about during these lectures. Others are Herb Simon, Daniel Kahneman, and Black and Scholes for option pricing models. So we're getting quite a tour of Nobel Prize winners in these 5 lectures. So let's dig in. Let's say a group is trying to decide to go to a concert. And they look and they see for this particular weekend or this Saturday night, whatever, there are 3 concerts available: a classical music concert, a jazz concert, and a punk rock concert. Each of the individuals have a preference among those 3 alternatives. One individual prefers classical to jazz to punk, another individual prefers jazz to punk to classical, and the third individual prefers punk to classical to jazz. These are 3 quite reasonable and rational rank orderings on the part of these individuals. Now, how do we decide what to do? What concert do we go to? Well, if we prefer classical, look at classical versus jazz, you can see 2 out of 3 prefer classical. If we compare jazz to punk, we can see 2 out of 3 prefer jazz. If we compare punk to classical, we see 2 out of 3 prefer punk rock. If we put this all together, we see classical is preferred to jazz, which is preferred to punk, which is preferred to classical, which is preferred to jazz, etc. And so what we have here is a violation of our assumptions in Lecture 2 about the transitivity of preferences. But the key point here is that 3 or more very rational decision makers end up with a completely irrational decision. There's a book a few years ago called The Abilene Paradox. It was published. And in it, these people in Abilene are trying to decide where to go to dinner. And they all have differing preferences like this. In the end, they go to the restaurant that they all least like. Okay? And part of the rationale is that if they go to any other restaurant, someone is going to get their preferences met better than others. But if they go to a restaurant that they all hate, no one will like it more than others. That's an odd case, but it's an interesting example of how completely rational individual choices can result in irrational group choices. So Arrow's more formal statement of this is that first, if we have at least 2 groups of individual, at least 3 alternatives, and a group ordering is specified. He makes that assumption. A group ordering is specified. If the group ordering yields A greater than B and any modifications are in A's favor, it'll still be A preferred to B. If an alternative is eliminated and all the individual group orderings remain unchanged, the group ordering will remain unchanged. For each pair of alternatives A and B, there is some set of individual orderings such that the group prefers A to B and no individual preferences can dominate. So he states this all in his 1963 book. and then comes out and mathematically proves that's not possible. Okay? That a rational group ordering is not specified for all possible outcomes. What this means is there is no way of coming up with a method of combining individual rational choices into a rational decision that will always work. We must allow interpersonal comparisons of strengths of preferences to avoid this difficulty. Well, what are we going to do? We have to make decisions. Basically, the approach we're going to adopt is called the benevolent dictator approach. And basically, people's individual value functions can be viewed as the attributes of the dictator. So the dictator does not have preferences over the attributes of the alternatives. The dictator has preferences over the preferences of the other people. Okay? And we can show that this is additive if we follow these conditions 1 and 2, so we can get an additive function, which we often have to use, as you'll see, in some really complicated tasks. I wanted to show you one little interesting side of the multilinear function compared to the additive function. Let's say we had 3 choices. One choice is one person gets everything they want, the other person gets nothing. Another is either one of the people get everything they want. The other is they both get everything they want or they get nothing. Now, most people would consider this to be a more equitable choice. Everybody benefits or loses in the same way. Okay. Let's look at our utility function. If we had just a simple additive function, it's insensitive to that equity issue. But if we have a multilinear function, it is sensitive to the equity issue and attaches a little bit of value to everybody getting some benefit. Okay, now let's put this to practice. As I mentioned before, I spent quite a few years away from academia, starting 2 software companies. And one software company had a suite of tools for new product planning, technology portfolio analysis, market assessment, etc. And our most popular tool was the Product Planning Advisor, which we sold many thousands of copies and did hundreds of engagements helping people decide what to put in the marketplace. For example, this tool was used in the initial planning of the new Mini Cooper when Rover was still in charge before they were sold to BMW. We'd identify the goals in the marketplace. What do we try to accomplish with this new product? And then we start to identify the stakeholders. So here we have a particular product, a grocery buyer's assistant. A grocery buyer's assistant is a product to assist you in the grocery store in locating and obtaining the products you want. And this product had been launched before in a grocery store and failed. And the question is try to understand what is it about the product we need to do to make it successful, to put this computer in your carriage so you can actually get some guidance as you go around the store. Okay. Here we have customers, the people who want to buy the groceries. Here we have clerks who work in the store, the maintenance people, the people who manage that particular store, and corporate that actually owns all the stores. The customers in this case are ranked the highest, but we can vary these things. For example, we often would rank the customers 5 and everybody 1 and see what the results look like, and then rank the customers 1 and corporate 5 and see what it looks like. And basically, as you expect, the customers want great features and functions for a very low price, and the corporate wants to give you as little as possible for a very high price. By looking at those 2 extremes, often we could creatively identify new alternatives that actually were between the 2 that were actually very successful. What do these people care about? Well, in this case, we have 38 attributes. This dictates one thing in particular. It will be an additive model. It won't be a multilinear model. There are just too many combinations of variables to consider. Here we have what people consider. We have the total time it takes you to use this, the device, the quality of the groceries you get, the suggestions you get, how intrusive this is in your grocery experience, the assistance it gives both to customers and to the clerks, the maintenance of the thing, the acquisition costs, etc. So 38 attributes altogether. We then have how the different stakeholders feel about attributes. So you can see here customers have preferences over these times and quality. Okay. The clerks are really concerned with does it support their job. The maintenance people are concerned with mean time between failure, MTTR. You can't see it, but corporate is really concerned with the financial sides of this. Each one of those cells in that matrix is filled with a utility function. This specifies the function and who cares about it. You can pick a functional form. You can take the mouse and drag that form around and change its shape. and you can say how important that is to that stakeholder. So one of our set of coefficients are how important is a stakeholder to the benevolent dictator, the overall decision maker. Then another set of weightings is how do the individual stakeholders care about the attributes of importance to them. So we put all that together, we do our calculations, and we get our results. Now notice we have here the status quo. It is 0.616. In-cart is 0.592. These are all on a scale of 0 to 1. The status quo is often a very important competitor. The status quo is compelling in the sense that you're already doing it. You don't have to buy it. It doesn't take any time to learn how to do it. And so it's often a very strong competitor. And in this case, at this point, it has a higher utility. In other words, this in-cart solution that we've designed is worse than nothing. We've created a product that is worse than not having a product at all. So we get a challenge. We can see here from a technical point of view, the validity metrics. It solves the problem much better than the unaided human in terms of the optimal route through the store, the most efficient path through the store. But if we look at the acceptability, this is almost perfect, 0.96 versus 0.53. People actually like the way they buy groceries now, and they find the cart is obtrusive. And then here we have a smaller difference, but basically for the status quo, it's a viable solution, less so for in-cart because it just doesn't seem worth it using it. And as you can imagine, going into this and when you get in the grocery store, have to type your whole list in, that even assumes you have a list. So how do we improve this product? So we went and we got 38 things we could vary. Which ones do we vary? So maybe we'll try to improve the user's experience with locate time, obtain time, indent time, learn time, and we change it by 10%, 20%, 30%. And you see it improves it a bit, but it really doesn't make it a big success. And if we look at how the times are being changed, once you get these times down to 0, there's not much else you can do. I suppose you could have negative times if the system was clairvoyant, and it would know what you wanted to buy before you knew it. But that's not very realistic. So we cannot improve the user experience to make this product a huge success. We could improve the financial value proposition. And here we're going to improve payback time, sales increase, and inventory turns per year. We can get a dramatic improvement, very competitive product. But then you might say, how can I do this? How can I make it such that the product is so cheap? Can I actually make money then selling grocery buyers assistance? The answer is that the way you do this, once you see these results, is you switch from selling the product to grocery stores to leasing the product to grocery stores. And that changes the financial equation and makes it more attractive. So in the end, by the way, they didn't go back and put this product back in the market. This analysis basically showed that it was very hard to make this compelling to customers. They were at first intrigued when they tested it in the market, but quickly they lost interest in it. They didn't want to use it. It was in the way. One amusing story is we were going through and looking at people in stores and asking what their preferences were. One woman said to us, well, you're going to have to make sure that it passes the Coke test. And we said, well, what on earth is a Coke test? She says, the Coke test is when my 4-year-old pours his Coca-Cola into the machine. Okay, let's summarize with 2 key points. First of all, this overall assessment, here's a way to think about it. We have strategies. They may be marketing strategies. Sometimes we help companies with which market segments to put the product in first. Or we may have investments. We may have technology investments or investments in developing things. These alternatives have attributes. They're attributes of the alternatives. Okay? And they have probability density functions for those attributes that have some uncertainty associated with them. It may not be all the attributes, but some. Okay? The utility functions don't depend on the alternatives. They depend on the stakeholders. What do the stakeholders care about? What's important to them? Okay? And the weights also depend on them. From the alternative point of view, there's no correct weights. From the stakeholders' point of view, there are correct weights that reflect their preferences. So the characterization of the stakeholders and the characterization of the alternatives come in to give us our overall expected utilities, which of course depend on both the alternatives and the stakeholders. One more piece. We have to come back to our benevolent dictator. Okay? The benevolent dictator has a utility function that includes everybody else's utility functions. Okay, so everybody else has a function across some M attributes, okay? But the one decision maker has a utility function across the utilities of all of the stakeholders. And that's our overall benevolent dictator formulation. So it's actually pretty straightforward as to how we structure it. Let's talk about where we go from here. Okay, at this point, we've been able to deal with uncertainty by using utility theory to formulate functions that take into account how you feel about risk. In the next lecture, we're going to talk about different ways of dealing with uncertainty. In particular, how can you stage decisions so that you can not make a full commitment until the uncertainty is reduced or played out. So the market opportunity, for example, has matured. The technology that's the winner is clearer. Okay. That'll be the next lecture, and we'll use option pricing models to talk about that. Okay. And then the fifth lecture we're going to talk about is behavioral economics, and that's how does all this theory compare to the way people actually make decisions? Well, it turns out it doesn't explain very well how people make decisions. It doesn't explain how they pick their next car or what pizza toppings they want. Nevertheless, decision makers often want these techniques when they have to make a big decision. A big decision, what company do I buy? What technology do I invest in? Those big decisions, often decision makers want to be more formalized. And in the fifth lecture, we'll compare the formalized methods versus the behavioral methods that just reflect the way people actually make decisions. So that's it for today. We've handled the issue of multi-attributes and multi-stakeholders. And next time we'll look at how do we stage the way in which we address uncertainty. Thank you.